And for those that were here last day, we kind of did some analysis, and this was kind of our final conclusions. If we have a finite state machine with an asynchronous input, each asynchronous input change must be captured by only one D flip-flop when entering a synchronous circuit, which means the parent state branches of an asynchronous input into two child states reached by the branch must differ by exactly 1 bit. So the child states can only differ by 1 bit. And we also saw another super important conclusion was that if you take an asynchronous signal and you pass it through a flip-flop, then it becomes a synchronous signal under most circumstances. And that we also like to double flop it just to make sure we have a maximum amount of time for it to recover from any metastability. So those were two big important things. And then the last thing we did is we had a bonus question, which I'm going to redraw here. It kind of looked like this. We had a OR gate going into a flip-flop. And then we had an AND gate going into another flip-flop. Like the D inputs. This was our clock. And we had A state, came around, went into this one, went into this one. We had the B state, it went into this one. Then we had this X, which was asynchronous. And it came in and it went there, and went into there. Yeah. And the question was, is this state machine okay with this asynchronous input X? And to figure that out, you have to generate a state table or a state diagram. Let's just do a state table. We can do both. So let's say our current state, we have A and B, and we're going to have a next state. And we're going to call this, sometimes we used to call this A plus and B plus. And we're going to have X equals 0, A plus B plus. And we're going to have X equals 1, A plus B plus. Kind of running out of room. I'm going to move this. X. Okay, so let's make this little table. And we have 0, 0, 0, 1, 1, 0, 1, 1. Okay. Okay, let's see. For A plus here, if any one of these bits are 1, A plus is going to be 1. So if X is 1 here, A plus is always 1. Right? And if X is 0, if A or B are 1, it's a 1. So X is 0, this is 1, 1, 1. Okay? And then, so this will be a 0. And anytime this is 0 is A, B, and X are all 0. And then for B plus, both X and A have to be 1 for it to be 1. Or so. So A, if X is 0, B plus is 0, right? And if X is 1, then A has to be 1. Or if X is 1, if A is 0, it's 0. So that's a 0, and that's a 0. And these two are 1, right? X is 1 and A is 1. Yeah, so that's the state table. And so to figure out whether this is okay or not is we need to look at these child states. So this row, these are two child states. This is a child state here, 0, 0. And this is a child state here, 1, 0. So they only differ by 1 bit, the A plus bit. So that's okay. This is a 1, 0, and that's a 1, 0. They're the same, so there's no difference. That's okay. And this is a 1, 0 and a 1, 1. It differs by 1 bit, the B bit. Okay. And this is a 1, 0 and a 1. It just differs by 1 bit, the B bit. So this is okay. So this would be fine. You could pass this asynchronous signal X into the state machine. You never have two child states differ by more than 1 bit. So it's fine. That's how this is okay. That's the answer. Now, if we want to do a state diagram, we would say, okay, if I'm in state 0, 0, I can go back to 0, 0 or 1, 0. This is X equals 0, X equals 1. And if I'm in 1, 0, if I'm in 0, 1, I always go to 1, 0. 1, 0, 1, I always go to 1, 0. Oh, sorry. Right? And if I'm in 1, 0, I go to either 1, 0, X equals 0, or I go to 1, 1, and X equals 1. And if I'm in 1, 1, I can go to 1, 0 or 1, 1. So I can stay here, or I can go back here. And this is X equals 0, X equals 1. Yeah, so that's the state diagram. And if you look at that state diagram, there's never two child states that differ by more than 1 bit. So you can do it either way. But I guess to do the diagram, you kind of need the state table. So it's easy to just do the state table. Any questions about that? No? Okay. How many people we got here? 39. Whoa, a whopping 39 people showed up. That means we can have some more bonus questions. Let's see. Can I turn on the grid? How do you turn on the view?